Okay, now in this one, we have a window or a gate, I guess it's calling it, and but it's at an angle. Okay, so what are we going to do about that? Well, let's zoom in on this just a little bit. So now the pressure in the water spreads out in all different directions, which means that the force acting on any little tiny bit, okay, here, maybe we'll call this a dF. All right, we can actually, we could integrate across this whole thing here because it's just asking for the magnitude. All right, and we could do it that way. We could, but that's kind of the scenic route. And I'm a little more interested at this point in the semester at just getting a home. Okay, so we're not going to integrate along the path from A to B. Okay, although we could, but we're not. So let me pull that off of there then. What we're actually going to do then is we're going to take this df and we're going to split it into a dfx and a dfz. Okay, now what that's going to do for us is it means we're going to end up with an fx, which is going to be this, our dfx, and an fz, which is going to be this, our dfz. Okay, just like that. All right, now then once we have, oops, sorry about that, I didn't notate that very carefully. This little guy here, that is a z. All right, once we have our fx and fz, what we'll do is we'll combine them. They're at right angles, and so we'll just say that our total force is fx squared plus fz squared. Okay, that's going to be our force. All right, and that works really, really well. Okay, especially since, remember, we haven't seen this in a little while, but they say magnitude there. Okay, whenever we see that, kind of be thinking in your mind, oh, I bet at some point I'm going to have to do a Pythagorean thing. Okay, all right, so let's get those bits then, the fx and the fz. Now, so let's do the fx first. Okay, so our fx, all right, we're doing this thing right here. Well, that turns out to be just exactly what we've been doing. We did in the last example. Okay, it's kind of like we've got a vertical window and we need to integrate from 0 all the way down to 2. Okay, so that means that's going to turn into rho gy, and then we have the integral z dz going from depth of 0 to a depth of 2. Okay, and so then that turns into 1/2 rho gy z at the bottom squared plus z at the top squared. I mean, not plus, but minus. Turn that into a minus. Okay. So we plug in our numbers. We get 1/2 onto 1,000. And it's 1.5 wide. At the bottom, we're at 2. At the top, we're at 0. Okay, and so that gets us to 29,430. Okay, and that'll be newtons, just like that. Now, for the sake of time and space, I haven't put my units in there, so forgive me for that. Or feel free to take off 1 point, whatever. Okay, now let's do the other one, the FZ. Okay, now this basically is going to be, well, it's basic to it. It's just the weight of the water. Okay, that's in this triangular portion right here. All right, so I'm going to have mg, which is going to be rho g times the volume. Okay. All right. So let's do that. So I got 1,000 and I've got 9.81. And again, I'm being lazy with my units here. My volume is, it's a triangle. So I have 1/2 base times height. And then my in my y direction, it's 1.5. Okay. Plug all that into my calculator, and what I'm going to get is 22,073. And that's newtons. Okay. So there's our x, and there's our y. All right. So what we need to do now is just put it together using Pythagorean's theorem. God bless the Pythagoreans, huh? Okay. And so we get in here, we got 29,430 squared plus 2273 squared. And our total number turns out to be 36788 newtons. Okay, or with 3 figs, we'd call it 368. Okay. Like so. Okay. Pretty straightforward. All right. Now, the one that we're going to do next is kind of similar. Well, it's very similar, but it's just kind of a little bit of a level up from this one. Okay. But we will end up doing an fx and an fz, and then combining them with Pythagorean's theorem. All right. So we'll get into that, and that'll be our last video on the fluids.